Glaciers are melting particularly fast in the Arctic and places like Greenland because of what scientists call feedback loops. A feedback loop is a change of cause and effects events that loop back to influence itself or the condition that is changing. A negative feedback loop reduces a change. A change in an event results in the opposite change in the next event. A positive feedback loop enhances or increases a change. A change in an event acts to increase that direction of change in the next event. For example, the interaction between warmer temperatures, melting ice, and open water forms a positive feedback loop. Take sea ice near Greenland. The warmer the temperature, the more sea ice will melt. The more open water there will be to warm up in the sunlight, which will cause the temperature to warm even more, causing more ice to melt, creating more open water, warming the temperature even more, and so on, increasing the change. This positive feedback loop occurs because of albedo.
I look to see how the changing albedo of the Arctic sea ice cover impacts climate change, how it impacts the sea ice and how those impacts change climate. As you heat up the water, you melt ice, you create more open water, you heat up more, you get more melting, and it's a feedback process. And those feedback processes are really important for climate change studies. So I have these two pieces of foam. One is white, one is black. One reflects lots of sunlight, the other one doesn't. Now, if we use our imagination, we can consider these not to be two pieces of foam, but we consider this to be an ice sheet, and this to be the ocean. So what we're going to do is just lay these down in the sun, and I'll quickly measure their temperature. That heat that's being absorbed in the ocean would start melting the ice. And what you would have is the ocean melting the ice back and back and lowering the albedo of the whole system.
In the last century, we have observed a significant increase in temperature related to increased CO2 and other greenhouse gases in the atmosphere.
Greenhouse gases are what keep the heat in. They include water vapor, carbon dioxide, methane, and others. As concentrations of these gases increase, the more heat is trapped and the warmer the Earth becomes.
Model results show that the temperature anomaly observed in the last 50 years is explained by external forces, not by natural causes alone.
What this means is that human activities are changing our climate. Scientists are working in Greenland and around the world to create computer models to predict what these climate changes will look like in the next 10, 20, 50, or even 100 years. In your lifetime, have you noticed changes in the climate of the place that you live? In the sea, land, plants, animals, or weather? Have your parents, grandparents, or neighbors noticed changes? In what ways can you imagine your home landscape changing if the climate continues to warm and the ice in Greenland continues to melt? Are these good changes or bad changes? Or are they both? In these videos, we have explored how scientists turn to the Greenland ice sheet to answer these questions by understanding how a glacier forms and moves, learning to sample and read the information contained in the ice, looking to the landscape for signs of past glacial extent, and examining how current feedback loops are influencing the current melting of the ice, we can start to piece together the puzzle of what happened in the climate of Greenland's past, what is happening now, and what might happen in the future. If you are interested in how Greenland is changing and will change in the future, get out there and study it. Ask questions and get in touch with us. Hopefully, we will see you along the way.